So as we have discussed in the previous part, that we are going to model the condition probabilities using phi of xi, the mapping function f, directly models the conditional distribution of yi given xi, and the distribution is parameterized by the parameter w. So we also consider this, that the derivative of the sigmoid function is a sigmoid function times 1 minus the sigmoid function. So let's assume that the function f, that the function f represents the probability of yi being 1. So the probability of yi being 0 is just 1 minus this function. So 1 minus this function is the probability of yi being 0. So in the last lecture, we discussed the likelihood function and the maximum likelihood estimate of the parameters w. And since we are modeling the probabilities, so we can write the likelihood of the parameters as so the likelihood function then becomes so we can write the probability the conditional probability of yi as simply, since we are assuming that y is either 0 or 1, we can write this as since we assume that this represents the probability of yi being 1, the power yi times 1 minus the power 1 minus yi. So you can see that when yi is 1, this equation gives us, when y is 1, so we can put yi, probability of yi being 1 given the xi and parameterized by w is simply, this is 1 and this term becomes 0 when y is 1. So this simply becomes fw of phi of xi, and when y is 0, so we can plug in 0 over here, so this will become 0 and this will become 1. So again, so this equation by choosing the value of yi, this equation gives us the same thing, that we assume that the probability of yi being 1 is represented by the functional mapping, and the the function directly maps the conditional distribution on y is equal to 1, and the probability of y being 0 is just 1 minus the function. So now we can write the likelihood as probability of y given xi parameterized by w, and we can plug in this equation over here. So this becomes phi of xi to the power yi times 1 minus function of phi of xi to the power 1 minus yi. So this is the likelihood function. And now, as you can see, the function of w that increases this probability on the right hand side is the one that maximizes the likelihood function. So as usual, as we saw in the last part of the last lecture, we are going to maximize the likelihood. So the optimal parameters w, or the maximum likelihood estimate of w, or we can write this simply WMLE, the maximum likelihood estimate, or simply W star, is argmax over W, likelihood of W. So now we are going to maximize this likelihood function to compute the optimal parameters, or the maximum likelihood estimate of the parameters W, which is W star. So the next part of the lecture will show how to do it.